So this lesson is all about graphing polynomial functions by hand. And so basically what you do is you use synthetic substitution to find coordinates on the graph, and then you need to just draw the curves from there. Now end behavior is a key part of that. You need to know what the graph is going to do far away from the origin. So the end behavior is determined by the degree and the sign of the leading coefficient. All these graphs, f of x equals x squared, x to the fourth, x to the sixth, they all have even degrees and positive leading coefficient. So when you go far away from the origin, both directions, the graph increases. So it rises to the left and rises to the right. That's what the end behavior is called. This next group, even degree, negative leading coefficient, they fall to the left and fall to the right. The further away you go from the origin, the graphs eventually fall in both directions. This next group is positive leading coefficient and odd degree. So odd degree, notice that it rises to the right and falls to the left. And that's true for any odd degree polynomial function. If you get far enough away from the origin, eventually falls to the left and then rises to the right. When you have a negative leading coefficient and odd degree, you get the opposite. When you go far to the left, the graph rises. When you go far to the right, the graph falls. So how is this helpful? Well, look at this example. You use synthetic substitution to get a bunch of coordinates, and you can see the coordinates there for step number 2 here, right here in the middle. But then how do you connect them? And how does it look? Well, you need to know end behavior. This is odd degree and positive leading coefficient. So that means it falls to the left, rises to the right. So then the curve is drawn that way. See, it falls to the left. As you go to the left, the graph decreases and rises to the right, and then you just kind of follow the points to draw the curves. So that's how you use end behavior to help graph polynomial functions. And that's the big picture.